Hello, here is Michael Pulin. I continue presenting pattern distributed transactions for microservices. Part 4, Fortifying Orchestrator. In distributed transactions, every element is associated with certain risk. In microservice choreography type of transactions, such as provided by Saga pattern, each participant is crucial because if it breaks, the whole transaction will be lost and compensating mechanism usually doesn't work. The major risk of managed transactions in the orchestration is the orchestrator itself because it represents a single point of failure. If you have several microservices involved in the distributed transaction, guess what would be more sufficient to protect all participating microservices or just one to keep the transaction go. To resolve this problem, the orchestrator must be durable. This can be achieved via combination of resilient deployment and runtime failover patterns. Particularly, if the transaction is triggered by a push mechanism like API or push event broker, we recommend SIB pattern for triggering the transaction. If the orchestrator has to pull triggering events, we recommend tandem pattern for this case. Both mentioned patterns are not about load balancing between the resilient instances of orchestrator. The URL or application or network load balances do they work well, but they do not operate at the level of microservices deployed in containers. For example, Kubernetes delivers load balancing at the level of pod, not microservices. If a problem is not in the connectivity but in the orchestrator itself, neither fallback or circuit breakage pattern can help. This is why SIB and tandem pattern introduce alternative orchestrators for the same distributed transaction. The optimal case is when the trigger and the orchestrator itself are under the same ownership. So the trigger can be aware of how the orchestrator may be invoked via API or push-pull events. It is recommended that the trigger uses a health check pattern before pushing an API call or event to the orchestrator. So if it is a poll-based event, then orchestrator should be implemented in tandem pattern, as I said before, with properly configured checkup frequency between the instances. As any microservice, an orchestrator can fail without properly logged notice about this event. The trigger is additionally obliged of providing appropriate logs in the case of orchestrator failure. The orchestrator has similar obligations regarding the failure of any of its supplemental microservices. Now, let's review the interactions between the orchestrator and its supplemental microservices. An owner of the transaction or developer cannot enforce particular design on supplemental microservices in all cases, but the developer or owner of the orchestrator have to take care of selecting such supplemental microservices that provide alternatives of supplemental microservices via SIB or tandem pattern. The simplest case for designing an orchestrator is when all supplemental microservices use the same interaction mechanism, pull or push. If the orchestrator or its supplemental microservices uses event sourcing for interactions, It is also okay because it can be viewed as a subset of the pull-push events. The most complex case is when the different supplemental microservices use different interaction mechanisms. The orchestrator should be aware of each interaction mechanism and realize it for each process step. To the degree this loosely couples the orchestrator with the interfaces of its supplemental microservices, not with microservices themselves. As a result, a change in the interaction mechanism of any supplemental microservices leads to redesign, rebuild, redeployment of the orchestrator, which is not good. Thus, one of the best practices of transaction design and deployment is in avoiding a change in the interaction mechanism in supplemental microservices by all means. The same was recommended to the services interfaces in SOA before. A change in the transaction logic may impact the choice of supplemental microservices. Even if Orchestrator can upload a new transaction logic at runtime, it is not recommended because it can cause a high risk of break of the transaction. But if it is necessary, it is better to externalize the logic updates to the rule engine through the rule pattern and meticulously match it to the available and running supplemental microservices. Also, a change in the logic constitutes a new transaction, and this is a must-have understanding for developers, because new change in the logic might require different microservices altogether to work the same transaction. In a common perception that developers of microservices do not really concern with risks of internal implementation problems of supplemental microservices, there is one small trap. From technology perspective, it is okay because Orchestrator is separate, independent, and differently later developed microservice. Nevertheless, the business task which the distributed transactions should solve cares very much about the problems with the supplemental microservices. So, no transaction makes sense if it is not confident that the providers of its steps deliver reliable outcomes, like in this case, the audit record is not working from the microservice perspective for the order. Thus, as we found, mitigation for each risk, we can enumerate some of them in this last part of the slide. Actually, it is a combination of programmatic and design operational methods got together, and you can read them here and compare to the risks at the beginning of the presentation. So altogether, they can make Orchestrator microservice durable and even restorable from its persistent logs and survive the system failure. That's all for today. I thank you very much, and I hope to see you next time. Please visit my website, which is on the title screen.